The diagram shows a square, so you can see a square here. It's two diagonal, so we have a square, right? Two diagonals are shown. Let us name it A, B, C, D. So this is A, B, C, D. So the two diagonals are, can you tell me the diagonals? What are the diagonals here? Can you tell me the name of the two?
The
Mhm.
the two diagonals are B and D.
Please repeat.
Wait,
What are the
B
two
and D, the diagonal B and D, A and C.
BD and AC? You should tell in this manner. The diagonals are BD. This is the diagonal, and this is also another diagonal, right? And two line segments. So I am changing the color. These are the two line segment, and the special condition with this line segment is they are dividing, see, each of which connects two midpoints of the sides of the square. It means this is the midpoint of this AD, right? Let us name it A, B, C, D, E. This can be
Oh,
F, this can be G, this can be H. So this is equals to this, is this part is equals to this part. Similarly, this part is equals to this part, and this part is equals to this part. Are you getting this information? It is written clearly that each of which connects two midpoints of sides of the square. So now we have to find what fraction of the area of a square is the shaded. See, this is the shaded area. So now we have to find area of this shaded region upon area of the square. So what we can do, see, suppose the side length of this square is a, so my area of the square should be a square. Now I will try to find the area of this shaded region. If I get this, I can solve this area. I can get this answer. Okay, so how we can find this area of the triangle GB, and we can name it I. So how we can find the area GBI? So see, can we find that GB? This GB should be a by 2 because this is the midpoint. This GB should be a by 2. This GB should be a by 2. This HB should be also a by 2. GB is clear. Can we find this GI? Can we find this GI? You know,
wait, just one.
there is one property of the triangle. There is one property of a triangle. In a triangle, suppose you have the triangle ABC, and if you have this midpoint of this side AB, if you have the midpoint of this side AC, and if you join these two lines, suppose this is the D and E, so DE will be parallel to BC. The first property is DE will be parallel to BC, and DE will be equals to half of BC. So please see, this GH should be parallel to AC. Why? I am considering this triangle ABC. Please consider this triangle ABC. Let me highlight this. So ABC, this is the triangle. In this triangle, you have a line segment GH, where G is the midpoint of AB and H is the midpoint of BC. So I can write that GH should be parallel to AC and GH will be equals to half of AC. Now we know the AC is the diagonal, and we know the formula of diagonal of a square. It should be root 2a, that is the a is the side length. So this is, if you simplify this, you will get a
Wait,
upon. Mhm.
so G, like, can you explain the like half thing? Like, can you explain what you just did there?
Any problem?
Yeah, I don't understand how you got like GH is equal to half AC. That again.
I have already explained the theorem here. This is the theorem. If you have a line segment in a triangle, right, such that D is the midpoint of side AB, E is the midpoint of AC, if you join D and E, the DE will be parallel to the third side, that is the BC, and it will be equals to half of BC. This is the standard theorem in the triangle of any kind of triangle. It is applicable. So if I consider my triangle ABC, G is the midpoint of AB, H is the midpoint of BC. So if I join G and H, GH should be parallel to AC, and GH should be equals to half of AC, and we know AC should be the diagonal, and the diagonal of the square is root 2a. I have simplified this and I'm getting GH is equals to a upon root 2. Is it okay now? So now if we have the GH, so we can find GI as well. Everything is symmetrical here, so GI should be half of this. GI should be GI should be half of GH. Can we say this? If you want, you can prove it also with the congruency condition. Otherwise, if you understand that everything is going to be symmetrical here, square is symmetrical everywhere, right? And the lines, all lines are symmetrical. So by assuming this symmetricity, I am writing directly GI should be equals to GH upon 2. Otherwise, if you say, I can prove it also. So GH should be equals to A upon 2 root 2. Is it okay? So now you have the GB as A by 2. You have the GI. Can we find the IB? Can we find the IB now? I want to find the length of this IB. Can you find this length IB? I want to find this IB. Is there any way to find the IB?
Like, mm,
I have multiple approach. For this question, you have multiple approach. See, the first approach is, again, if the everything is symmetrical here, so can you assume that this diagonal DB is going to be bisected in all equal parts? What I'm trying to say, this is the first part, this is the second part, this is the third part, and this is going to be your fourth part. Everything is symmetrical. So a dB is also the diagonal, so it is root 2a, and you have to divide it by 4. Why I'm done this? Because I'm assuming this everything to be symmetrical. So if you do this, what you will get? Can you simplify this? Or if you cannot simplify it, let it be, no problem. Is it okay? Now please see, I'm telling you that, please listen, I'm telling you that the angle between GI and IB should be 90 degree. I'm telling you that this should be 90 degree. Why? Let me explain. See, do you know that the diagonals of a square are perpendicular? Do you know that the diagonals of a square are perpendicular? Do you know this?
yeah,
And I have told you that GH is parallel to AC. I have already explained this, that GH should be parallel to AC. So if AC and DB is perpendicular, so why not GH and DB is the perpendicular? Are you getting the logic why I'm saying that this is also a 90 degree? Are you getting it or not? Are you getting it or not? Tell me clearly.
no, not really.
Okay, see, let me explain with the another clear diagram. See, I'm saying that this is the square A B C D. You have this diagonal, you have this diagonal, and I'm considering only this side. This is the G and this is the H. You know that this angle is 90 degree, correct? Diagonals are
Yeah,
perpendicular to each other. It means you are saying that AC is perpendicular to this red line, and I'm saying that AC is parallel to GH. Now I think in this pictorial representation you can correlate easily. This AC and GH are parallel to each other. Can you see this in the diagram? So can we say that this angle should be also 90 degree? Now please verify me. Is it okay to say that this angle will be also 90 degree, because these two are the
yeah,
parallel lines and this red DB line is perpendicular to AC, so the same line is going on, and AC and GH are parallel. So why can't we say that this angle is the 90 degree? Isn't it? Is it okay now?
yeah,
So now if you have this
yeah,
right angle triangle, so you can write the area of this triangular region, that is the half base into height, where base should be this GIC. This A by 2 is the diagonal. This A by 2 is the diagonal. This is the side opposite to 90 degree. So this is the diagonal. This is the hypotenuse. So you don't have to use this one. You have to use the base and the perpendicular. So GI should be your base. We have already calculated our GI. GI should be this one, a upon 2 root 2. This is the GI into the next one is this BI already we have this here. BI is root 2a upon 4. Now let us try to simplify this. See, this a square going to be cancel out. So now let us simplify it very carefully. See, this root 2 going to be cancel out. So what we are getting, 1 upon 4 upon 4, so 1 upon 16. So we are getting the answer as D, and I think this should be the correct one. Have you understood? See, this is the one way I have tried to explain you this.
Most, this is the most overextended question of all. Like year nine should not be learning this.
See, basically, I have explained each and everything with a mathematical explanation. Otherwise, if you assume everything to be symmetrical, if you consider this one, then I can minimize this solution. Otherwise, if you say no sir, how you can assume this one? So that's why I have explained each and everything. Still we can explain it in many ways. You have to understand the way of explanation. The way I have done here is, I have written the area of a square in terms of a, and I have tried to write the area of shaded region in terms of a and a will get cancelled out, and you will get your required ratio. No problem. See, you have to try to get as much as possible from this question. If you have any doubt still, now you can discuss with me. Yes, any doubt if you
Mm,
have.
no, I don't have a doubt.
Have you understood each and every concept, especially this concept? Have you understood this one, this concept?
Yeah.
Okay, so let us move to the another question.